In the previous lesson, we learned that 5G networks will greatly change the application of drones. Now, we will learn how 5G networks will make a difference to VR. What is VR technology? VR, also known as virtual reality, depends on technological devices to replace users' sight of the real world with a new independent virtual space. This enables users to have a more in-depth and immersive experience. The development of new technologies is displayed by the technology maturity curve, which indicates the hype of new technologies and concepts across different periods. New technologies usually go through 5 stages. The innovation trigger stage is when the technology is born. As the technology grows in popularity and garners reputation, it reaches the peak of inflated expectations. However, the technology faces new challenges, leading to bubbles. The technology remains in the trough of disillusionment before rebounding. With the development of the technology, the successfully survived operation model is widely adopted. The new technology steadily climbs up the slope of enlightenment and finally arrives at the plateau of productivity. According to Gartner's latest hype cycle for emerging technologies report, VR has passed the stage of bubble burst and entered the steady growth and recovery period. With expanding commercial use of 5G, the VR market in China is set to value nearly 30 billion yuan by 2021. Profits mainly derive from live broadcast, videos, and games relying on VR technology. Now, let's look at the application of VR in live broadcast videos. There will no longer be any need to regret missing out on a sports event, concert, or product launch event because VR Live broadcast can bring the event to you in real time and provide the ultimate immersive experience. Compared with ordinary live broadcasts, VR live broadcasts have many additional special features. VR is 3D, panoramic, and interactive. Panoramic cameras capture images from multiple angles, stitch them together, and transmit the final products to terminals. Interactive components embedded in the cameras allow users to select their favorite viewpoints, changing the original one-way transmission and pushing the limits of mobile phone screen space. Users are no longer a passive audience, but active participants. What changes will VR bring to gaming? Games have evolved from the earliest standalone games to 2D online games, and then to 3D games. Progress made in imaging and technology enables games to provide an increasingly involved, reality simulative experience. However, until now, technical limitations have limited players to being only outsiders to the on-screen action. The competition among game vendors has become increasingly homogeneous. The appearance of VR games that focus on immersive experience will certainly become a major change and turning point for the entire video games industry. In addition to VR live broadcast, videos and games, VR-based industry applications will increase exponentially in the future. Having said all that, what exactly is cloud VR? What are the differences between traditional VR and cloud VR? To find the answer, let's look at the technical principles of VR services. We know that VR is achieved when images are rendered by the server and then transmitted to the VR terminal through the network. In traditional VR services, images are rendered by local dedicated servers and transmitted to terminals through wired networks. In cloud VR, on the other hand, image rendering and processing are performed by cloud servers. Compared with traditional VR services, cloud VR has the following advantages and development drivers. For consumers, cloud VR can reduce the cost of experiencing VR services. Better user experience of traditional VR services depends on high-performance PCs or hosts for local image rendering. A set of VR terminals and matching high-end PCs, or hosts, costs over 10,000 yuan, which is far too high for many potential consumers. This also affects the development of the industry. After VR is cloudified, cloud servers can instead render large-scale images easily. Users would no longer need to purchase dedicated hosts for VR rendering. The overall cost is only 1/3 of that of traditional VR services, greatly improving the cost-effectiveness of customers' VR experience. The requirement of VR terminals is greatly reduced by Cloud VR, moving computing capability to the cloud. After VR is cloudified, logical computing and image processing capabilities are enhanced. Distributed computing capabilities of the cloud, the Hyper Multi-Core Server, and the Graphics Processing Unit, or GPU cluster, are well utilized. The latest GPU technology is used for rendering and artificial intelligence, or AI, analysis to compensate for the insufficient capability of the independent VR terminal, reducing the complexity of the terminal. In addition, unified rendering on the Cloud VR server can improve compatibility with accessed VR terminals. For the VR content provider, Cloud VR can aggregate content into an ecosystem and protect the copyrights of VR content. Currently, a large amount of VR content is offline and tough to manage, leading to difficulties in effectively protecting the copyrights of VR content providers. After VR is cloudified, data can be precisely managed and distributed on the cloud, and content can be managed and controlled in a unified manner. This solves the disadvantages of the currently isolated operation mode. Regarding the VR ecosystem, Cloud VR can accelerate the incubation of commercial appliances and increase the popularity of VR. Currently, the promotion of VR commercial scenarios remains sporadic and isolated. There are very few content sources, little promotion, and no virtuous ecological cycle. After VR is cloudified, the cloud will be able to aid promotion, greatly improving the development of a healthy VR commercial ecosystem. High-quality VR content and a new world of VR commercial opportunities will flourish. Cloud VR will bring about great change to traditional VR. However, these changes also bring challenges which must be faced. The direction of Cloud VR development should be based on user experience improvement. Service experience requirements include avoiding motion sickness, reducing delay, and enhancing immersion in terms of user perception, with additional rate and latency requirements placed on the network. The development and evolution of Cloud VR consists of 3 stages: the initial stage, comfortable experience stage, and ideal experience stage. These different stages bring different requirements for the network. First, let's look at the rate requirements of Cloud VR. The Cloud VR terminal for immersive experience has a higher field of view, or FOV, than traditional TVs. To achieve the same definition as that of 4K video, the resolution, frame rate, and bitrate must be far higher than in 4K video servers. Therefore, Cloud VR has higher bandwidth requirements for the network. The rate requirements of Cloud VR, according to actual test and theoretical analysis, are listed in the table here. For example, in the comfortable experience stage of Cloud VR, the bandwidth of a single service channel must be greater than or equal to 260 megabits per second. In the case of large-scale service development, requirements for 5G networks will emerge. Next, we are going to talk about the latency requirements of Cloud VR. Cloud VR latency mainly includes the cloud processing time, network transmission latency, and terminal processing latency. The latency of the end-to-end network must be within 20 milliseconds for a network at the initial stage. At the comfortable experience stage, however, the latency of a network is generally 15 milliseconds, and at the ideal experience stage, within 8 milliseconds. In the future, this ideal experience of Cloud VR can be achieved with low latency 5G networks. The preceding two factors have a great deal of influence on cloud VR experience. Aside from them, the packet loss rate, video resolution, and frame rate also play a role here. The development of cloud VR depends on the coordination of cloud, network, terminal, and operation. As cloud computing and 5G networks develop, and with the release of lightweight VR terminals, cloud VR based on 5G wireless networks will become applicable to more scenarios than ever before. You will soon find cloud VR in your everyday life. That's all for today. In the next lesson, we will talk about the impact on Internet of Vehicles from 5G networks.